DevOps stalwart is a partner with KPMG in cybersecurity practice. He comes with more than 22 years of experience in cybersecurity domain, working with global banks, energy firms, and technology companies. Let's all welcome our global leader, Mr. Chandra Prakash Suryavanshi, aka CP. Now, he's not joining us alone. CP is joined by his co-speaker, Ms. Pratiksha Doshi. Pratiksha works as an associate partner in the cybersecurity service line at KPMG. She leads the threat and vulnerability management at KPMG and has over 16 years of experience in cybersecurity areas. Through their power talk on building and maturing Secure Devops Pipeline, this dynamic pair is going to share the golden nuggets of insights on the key principles to be followed while building Secure Devops Pipeline. Ladies and gentlemen, it's now time to hear it out from the duo, Mr. Chandra Prakash Suryavanshi, aka CP, and Ms. Pratiksha Doshi, taking charge of your screens right now.
Hi, I'm Pratiksha Doshi. I'm an associate partner with KPMG.
Hi, this is Chandra Prakash. You can call me CP. I'm a partner in KPMG in India in the cybersecurity practice. First of all, I would like to welcome everyone on this DevSecOps Summit 2022. And I am really appreciative of the fact that you are giving your valuable time today. So let me start with some context and what we are going to see today in the interesting topic, which is maturing and building DevSecOps lifecycle. Today, we are going to see this presentation in three formats. One, the rise of Secure DevOps, building blocks of Secure DevOps lifecycle, and finally, Secure DevOps maturity model. So let me start with some context on how this entire application development has evolved from waterfall model to DevSecOps over a period of time. In the beginning, there was a waterfall model. This model was largely used by all application and product development firms to develop applications and products. It had 5 large phases. First, the requirement, wherein you understand the product requirements and then define the security requirements, which is functional and non-functional requirements, and you create this document. Then you design the application, both high level, low level, develop security architecture. Along with that, insert the right security controls to put up the security architecture. Third is the implementation, where you do the software encoding, security coding practices. Then finally, the verification, and finally comes the production. So what was the challenge in waterfall model? First, this model used to take anywhere between 6 months to 24 months, which is a very long cycle of development. It does not allow any reflection or revision or a feedback from the customer. Hence, it is very difficult to make it as a changing or a working model. Second, it was very poor considering the complex and large projects because you cannot break it and you freeze the requirements till the time you get into the next release. Third, it was very difficult to measure the progress within these stages. And then fourth, it is very difficult to insert security. Security used to follow a governance gate process, which means that at each of the phase, you have to clear a security requirements. Then you can move the entire application or product lifecycle into a next phase. Without getting that clearance, the product does not move. Now, this is very inefficient. And last and final, integration and releases were typically very large. They were big bang. And any technical or business bottleneck, you cannot identify early. So what was the solution? The solution was that agile. So people started adopting agile method of application and product development. The objective of agile model was to ensure that faster and iterative release cycles are there. You have smaller teams and you get customer feedback on a consistent basis. So how the agile model used to work is that you break the larger product or project into a smaller chunks. And then you do one-time requirement analysis, gather the functional and non-functional requirements, develop the design, and then you have a shorter release cycles and sprints. Typically, the sprint ranges from 4 weeks to 6 weeks, and then you have a daily scrum to understand and identify the task on a daily basis. So this allows you to address rapid changes based on the testing and customer feedback. Now, what is the disadvantage? Obviously, the agile model also comes with disadvantage that you have a lesser documentation and also you have a maintenance and operations issues. And then finally came the DevSecOps. So what does the DevSecOps mean? DevSecOps typically mean that you have a development and you have an operations team. They work on a consistent basis, which means that releases sometimes are not only on a weekly basis or a monthly basis, like what you used to do in Agile, But in fact, sometimes you can have a release on a daily basis. You can do bug fixing on a daily basis, and in the near real time, whatever application development, feature enhancements, or a bug fixing you are doing can move to the production on the very same day. So you can see that there are certain overlaps between Agile and DevOps. While the Agile is also doing development starting, ending, and releasing, but DevSecOps is also taking it further to operations and integrating the operations part into the development. And as we discussed earlier, even in DevSecOps, you can follow an Agile model of smaller teams working on microservices and work on a continuous integration for the DevOps. What are the features and benefits about DevSecOps? One, it is that you can have more frequent and automated deployments, you have shorter lead times, and you're also adopting infrastructure as a code and adopting the security as into the DevOps lifecycle. So obviously, is it easy to implement DevSecOps? The answer is no. We know that there has been conflict between development teams and operations teams. On one side, development teams want faster changes. You see that operations teams actually does not need fast change. They need change advisory board. They need to move the changes into operations over a period of time. They have change advisory board, which takes sometimes 1 week to 5 weeks to really migrate the code to the production. So there is a conflict between the development and operations team. And how do you really handle this conflict? The right way to handle this conflict is through a framework-based approach, which means that you need to have the right building blocks of DevSecOps lifecycle to ensure that both development and operations team, in spite of having different objectives, work together in tandem. So what are the building blocks for a DevSecOps? DevSecOps is not just a set of pipeline or a set of tools that you automate. Many people misunderstand it, saying that DevSecOps means automated application development, where people can develop code and multiple people can check in the code into a pipeline, and the pipeline will be automated all the way to the production. And there will be respective tool set that will be integrated into it. But that's not appropriate definition of a DevSecOps. To really become a successful in integration and working together in DevSecOps with efficiency and effectiveness, you need right governance, you need culture of shared responsibilities, you need automation in CICD pipeline, you need to have a right metrics, and you also need to ensure continuous compliance. So with this, let's see what are the building blocks, and I will hand it over to my colleague, Pratiksha, for taking it forward. Pratiksha, over to you.
Thank you, CP. So first one is the culture of shared responsibility. This is a very important building block of DevSecOps, as already emphasized earlier. This it means that successfully the development team, operations team, and security team needs to work in a collaborative manner. In order to work in a collaborative manner, we can build a security champions program. Security champions program consists of three main aspects. First is establishing governance, which consists of defining a framework, development of DevSecOps policy, socializing the policy within the organization, and also defining roles and responsibilities, KPIs for development team, operations team, and security team, so that they understand what are their roles and responsibilities in order to have an effective security and governance. Second one is training. So training across development teams and operations team and the product teams. So there are two types of trainings which are generally conducted across the organizations. One is the awareness-based trainings, which is a generic training, which could be secure SDLC training or a secure coding practices training, which the developer, which is imparted to the developer, and then the developer can use that knowledge in their day-to-day development lifecycle. The second one is activity-based training, which is more of an in-depth and a detailed training, which any security champion should undergo, and which can be, which is focused on a particular topic, which could be threat modeling, for instance, security testing of a mobile application or an API-based testing, or how can security champions really help the development community to remediate and fix the issues. The third aspect of a security champion program is building guardrails. So guardrails are nothing but building fences, helping and enabling developers, product managers, security team, operations team to build security products. So there are two types of guardrails which typically exist. One is for the operations team and the other is for the development team. For the development team, the guardrails are, we can create templates, we can create small security functions. The templates could have prescribed authentication functions, so how the developer needs to call for an authentication function, or how they can call a password management function, or a pre-built security functions for doing data validation, like input validation. How can they call security vaults, etc.? And they can embed those kind of code snippets into their code without really worrying on how they will do a secure programming. The second type of a guardrail is for the operations team. Similarly to as a development team, the operations team also we can create templates for them, which is called as typically infrastructure as a code, where we must have heard that there are Terraform infrastructure code templates, which can be created to build secure images, to build secure configurations. And in this way, security by design as a culture can be inculcated in the application and the infrastructure. That's how we can build a successful security champions program. And this is a very important aspect in the DevOps and Secure Devops processes and lifecycle. Let's look at DevSecOps reference architecture. So as we know that SDLC consists of multiple phases, which could be typically plan, coding, development, deployment, testing, and operations. So as you see here, there are multiple phases to the SDLC life cycle, and security is embedded in all these phases. So security is embedded in two ways. One is with the help of processes, embedment of processes into each of the phases, which could be, for example, security understanding requirement, performing threat modeling, imparting security training, and then putting security testing controls, security scanners to ensure that the code is secure, and then moved on to the deployment environment. And the other is, and from the process aspect as well, security has to be embedded across each of the SDLC lifecycle. So we will see in detail in the next upcoming slides of how we have been able to automate one such CICD pipeline, and how we have been able to integrate tools and enhance the security posture for an organization. Let's look at a CICD pipeline. Let's take an example of an organization which could be having 2,000 developers, about 300 to 350 applications, and approximately 8 people who are managing application security in the organization. Now, in order for the application security team to have an effective risk management and effective compliance across the application lifecycle, automation was the key. So we can integrate a set of security tools into each phases of the SDLC lifecycle, automate it, centralize all the security findings, and have an effective security management, risk management, and governance in place. So let's start from the left-hand side here, which is application. Step 1 is application profiling, which is done typically at threat modeling, at the planning phase, where the application is profiled in order to identify what kind of application it is based on the types of users, interfaces, the data it handles, and then the application is identified and profiled whether the application is high-risk application, medium risk, or a low-risk application. Once the application profiling has been done, then the next steps of what all security testings which needs to be conducted can be decided, whether a comprehensive risk assessment, privacy assessment needs to be carried out or not. So that's the first step in the planning phase which needs to be carried out. Once the application profiling is done, there comes threat modeling as an exercise, which threat modeling is a method to identify security risk right at the design stage of an application. It is typically done on the blueprint of an application, and the data flows are studied to identify what could be the potential risk to the application and what could be the controls and countermeasures that can be integrated in all the further phases of the life cycle, which could be coding, build, test, deploy. The third phase here, which we see, is IDE integration, which is integrating the security scan in the developer IDE. for enabling them to fix the security vulnerabilities right at the time when they are coding, so that the security issues are relatively lesser in the further phases in the SDLC lifecycle, and the issues would be much lower in the production and finally at the operations phase as well. So this becomes a very important aspect to do security by design, or by shifting left the security and then helping the developers to fix the security issues. As soon as the developer checks in the code into the security, into the source code repository, there is a Bitbucket webhook, which is an automated trigger for security scans which can be done, which are SCA, which is a software composition analysis, which is typically done to identify open source vulnerabilities on the libraries which are being used by the developers. So there could be known vulnerabilities of the libraries which the components have been used by the developer, and SCA typically identifies those bugs, and it can be remediated at that point in time itself. There is another piece where security scan can be done, secret scan can be done on the source code to identify any kind of hard-coded credentials which could be there in the application, and then it moves to then it is moved actually to the SAS scan. So in the SAS scan, typically all the issues and OWASP top 10 issues are identified for the source code. The SAS scan profile can be customized to either it can be a comprehensive SAS scan or a limited SAS scan based on the type of the application, changes which the application could be carrying on. So once the SAS scan is done, the application is built. The application is built on an image, and then it is pushed onto ECR, which is a registry. And then the image scan is performed on the application. And once the image scan is completed, to identify for any kind of misconfiguration which could exist in the images, to check for the hard-coded credentials, to check for any kind of file or network settings which could be present. The second last stage is performing the DAST scan, which is at the time when the application is hosted onto the Kubernetes service or which is deployed onto a server. There is a dynamic application security testing which can be carried out to identify security issues at the runtime of the application. And finally, all the security bugs or real-time attacks to an application can be monitored with any kind of SIEM or a monitoring solution for real-time tracking and detecting the attacks onto the application. All the issues which we have seen, all the security scanners which are integrated at different steps are ingested into a vulnerability management system or a bug tracking system. So bug tracking system or a vulnerability management system acts as a centralized dashboard for all the security issues. And then a manual verification is carried out by a security analyst to identify what could be the actual risk and remove false positives. And these actual issues are then fed onto the Jira and then onto the developer backlog to actually identify what are the risks which the developers can action upon. So this is a typical CICD pipeline where we have seen that all the security scanning tools are added onto all these phases. And then once they are added, a centralized bug tracking system or a vulnerability management system can effectively help in remediating and governing as well. This is a Jenkins file where we add different stages that I described in the previous slide. So the Jenkins file here is customized. There are various stages in the Jenkins file which we have seen, which could be coding, build, testing, and deploy. So the time of the build stage, there are multiple calls which are being done for various tools. So for example, here we see Git secrets. So Git secret scanning is done here, where it actually scans for secrets, it checks for the hard-coded credentials, and then identifies what could be the hard-coded credentials in the code, and that can be the pipeline can be stopped at that point in time. Similarly, software composition or a source code composition analysis with the help of dependency checker is also added in this Jenkins file. So this helps us programmatically trigger different scanners from the CICD pipeline, and Jenkins helps us orchestrate that. Okay. The third pillar here is, the third building block is measuring the success of the pipeline with the help of different metrics which can be which are defined. So along with multiple matrices of the CICD pipeline or a successful DevOps pipeline, security controls or security matrix is a very important matrices which also needs to be taken care of to actually see how the pipeline is performing from security perspective also. So so there could be how many security defects which the pipeline has, how many of them are recurring security defects, what is the mean time to detect the security issue, and how much mean time to remediate the security issue, how many of them are recurring issues, etc. How many assessments have been completed in the complete SDLC lifecycle. That is also an important control and a metric to measure in order to see how effectively the pipeline or security posture has been for the application. As I mentioned in the automation slide, there is a centralized vulnerability management which basically ingests all the security scanning tool output. Defect Dojo is one open source vulnerability management tool. It ingests the security scan results from all the security the scanners. Defect Dojo can be also configured to remove duplicate issues because there are multiple scanners which are integrated, SCA, SAS, secret scan, etc. So there could be multiple issues or duplicate issues which could be coming in. So Defect Dojo can be programmatically configured to remove the duplicate issues, to mark false positives so that next time, the second round of iteration, similar issues do not come up. And in this way, we can verify, track, and govern all the security vulnerabilities and help improve the security posture and focus our efforts into remediations as well. This is the final building block, which is configuration as a code. So as it is very well known that a lot of misconfiguration is a major risk in the cloud, which allows access to the attackers the organization's data is very widely accessible in case of there is any misconfiguration which is happening on the cloud. So, and that's why there was a need to have configuration as a code or a compliance as a code. It is widely used in the cloud environment. So compliance as a code automatically checks for security misconfigurations in AWS, GCP, Azure, and other kind of cloud environments. So in compliance as a code is a tool or a script which checks for the configurations, which collects the configurations from the cloud. It checks for weak configurations. It checks for the drifts in the environment, analyzes what kind of risk it possesses, and then gives the outcome. There are multiple solutions available in the market which are called as CSPM, which is Cloud Security Posture Management, such as Aqua, Dong9, and also there are cloud native utilities from AWS and Azure, AWS Security Hub, and Microsoft Defender, which can help us to identify what could be the potential misconfiguration and also identify is there any non-compliances versus the various standards such as GDPR, PCI DSS, CIS benchmarks, etc. So this is a very important component to understand if there is compliance in the cloud environment on the continuous basis with the help of these utilities. Now that we have understood the framework and the automation, the key question here is, from where do we start? With that, I will hand it over to CP. Over to you, CP.
Thank you, Pratiksha. So I think one of the key questions that comes to the mind is that I may be mature, I may have few pipelines, and that's what we see in most of the organizations. Some of the pipelines are open source, some are on AWS, some are on Azure, and some of the pipelines are at different maturity level. Some are automated and some still have certain manual provisioning systems. So what do we do? The ideal way to start is that you should conduct your DevOps maturity cycle, and let me represent a framework for doing that. So in a DevOps maturity framework, you still have the same phases like planning, coding, building, testing, release management, deploy, and then run and operate and monitor. So in each of these phases, there are different set of questions that you have, and you can then measure your own maturity against that. So for example, in planning, how is the entire planning for a DevSecOps application development happens? Do we have a product or service with very clearly defined ownership? Do we capture all the functional requirement specification for minimum viable product? Do we have the security requirements integrated? Do we have the right resources and capacity management? If there are multiple microservices, multiple teams who are going to work on it, have we identified the right set of team leaders who are going to work on that? Have we defined security standards, coding standards for quality checks, data privacy review, threat modeling, etc.? Then we move to coding, build, test, release, deploy, run, operate, and monitor. The idea is that for each of these phases and for each of this subdomain, you identify a set of questions and you benchmark yourself from 1 to 4 and say 4 is the highest maturity level. What you will get in covering across planning, governance, processes, technology, automation, and operations and monitoring, you will get your own score saying that you are at say 1.5 on the planning phase, 2.5 on coding. Maybe you have done automation and fantastic job on automation. So you may be 3.5 in most of the automated cases, but yeah, on the compliance side of it, maybe you are 2. So that will give you a roadmap so that you can have a right framework and a roadmap to make all of your different pipelines consistent and have the appropriate visibility. That's the right way to start on the maturity assessment. Let me show you quickly about what are the myths and some of the hard ones lessons that we have learned over a period of time while working with DevOps pipelines. First, requirement gathering, threat modeling, and secure design are one-time project activities or application development activities. And then it only needs to be performed during major changes after the initial phase. And success typically lies in productizing the requirements. What do I mean when I say productizing the requirement? You know that developers are not typically security professionals. They don't need detailed security understanding. They believe in developing the code faster and focus more on functionalities rather than security. So if we ask them too many questions on application controls or threat modeling and use certain frameworks and models, they may tend not to address that. So if we productize threat modeling, which means that you have certain tools like SD elements, or you can productize using templates, then it becomes faster and easier for them to do. One of the best way that we have seen working is that for an application, when we do the application profiling, as a security team, we do our own threat modeling and then hand it over to the development team and the project lead so that they can do it on an ongoing basis. The second, I have seen that people believe that all of the security tools, which sometime back Pratiksha spoke about, can be integrated. It is not necessary that integration of all the tools in DevSecOps is possible and viable on day one. You can start with DAST integration, then you do the SAST integration, then move on to the compliance monitoring and like CSPM tool. Then you start monitoring, use the SCA, which is your software composition analysis, secrets management, image security, and then ID. Why I put ID in the end? I have seen that ID is something that scans only 1 to 2 MB of lines of code that the developer has put into its own ID before he or checks into the Git or any other Bitbucket or any other repository. And then if you do complete scan or the scan profile is not configured appropriately, developers typically tend to suppress that because it is going to take a long time and then there may be a lot of false positive. So when you're doing ID integration, you should ensure that you have configured the minimum scan profile like hard-coded passwords or input validation or another 4 or 5 profiling with respect to, say, sensitive data encryption, if it is a private encryption or a credit card information, so that developers don't waste too much of a time and a critical vulnerability bug can be identified early. Another lesson that we have learned is that there are so many security tools we are talking about. We are talking about ID integration, then SaaS, SCA, secrets management, and the outcome of all of these goes into a central defect management system. It is necessary because you cannot go and see each of the screen or console to see the findings. You have to centralize it at some place. And another thing is that people often complain that there are too many false positives. And if you directly integrate with bug tracking system like Jira and it goes to the developer as a backlog, and if it is a false positive, obviously then developers will tend to suppress them. So you should remove the false positive, play with tools like Defect Dojo, so that next time if the same risk or vulnerability or security implication is identified, it is suppressed, it is not marked as true positive, and then you can then integrate with bug tracking system so that all true positives get integrated into Jira. Another thing that we have understood is that DevSecOps is really more of a cultural issue. You need to have the right set of framework, you need to have the right set of governance. The roles and responsibilities between development team, security team, and operations team has to be very clearly identified. You also need to establish the appropriate communication channel. It can be on a daily basis, weekly basis. Try to templatize the communication as much as possible because that is what will address the larger issue of DevSecOps, and it's not really a technology issue. Another thing we have noted is that incremental scans, say for example, if you completely automate your SaaS, TAST, SCA and other sort of scans, whether you are changing just one line of code or updating your logo or a privacy policy or making any other changes, all of these changes which are minor also goes through the entire scanning cycle. This may delay. So what you can do is that you can leverage the orchestration tools. There are orchestration tools which, based on the criticality of the application and the criticality of the changes, allows you only to select certain tools, and only those tools or scan profiles can be run, and not all of the scanners and scan profiles can be run. Last, that you should track metrics for continuous security improvement, and whatever your lessons are learned from the incident, it can be misconfigurations on the cloud, it can be related to automation issues or feedback based on the design issues, and then address that. Or a feedback loop has to be configured so that you can make your entire DevSecOps lifecycle successful. So with that, I would like to thank you everyone. And if you have questions, please type in. We will be glad to answer them. Thank you.